My name is Ishan Ali, and yeah, I'll be your first presenter. Bastian asked me for if I can do a talk last week, so I didn't get a lot of time to prepare this, and this is the first time I'm presenting this talk, so I'm sorry if there's any mistakes. And also I have to admit that I had to borrow a lot of things from tutorials and books and stuff. So yeah. Um, First of all, who am I? Like, short introduction for those who still don't know me. I keep coming here, so you should know me. Anyway, I've been living in different countries, so I'm a bit of a nomad. And I work for a company called MyData. I just started last month, so don't ask me a lot of questions about what we do. I'm still figuring that out. But what I know is that we provide extremely efficient, I wouldn't say high, but extremely efficient storage to the cloud, to Kubernetes clusters through a mega project called OpenEBS. My job is to look at a specific project, a relatively new project in that space called called Maestro. So that's my job, and I've been involved in the FOSS community for a long time now, and my background was with GNOME and other, mostly Linux, embedded and desktop environment development. I love planes and helicopters. I had a helicopter license that I lost because of slow German bureaucracy, but I do have a plane license that I got in Germany, so I'm more or less thankful for that. And I love cats. Um, I'm also a member of Async Foundation's working group in Rust. I don't know how I became part of it, but somehow I did. But I did contribute a bit, not recently, but for a while I did. So let's get into it. Like, what am I talking about? First of all, what is it with async? Why async? It's basically about concurrent programming. When I say concurrent programming, first question that people would ask, why not just use threads? And yeah, you can use that. And also Rust has libraries in the standard library for that. You can do that certainly, but it depends on your use case, right? Threads do have an overhead, so you have to ask yourself, like, is your workloads there CPU bound, or are they more IO bound? Because if they're IO bound, you mostly spend time waiting, and if you just want to wait, you don't want like lots of threads launched just to wait, because threads, as I said, have an overhead, especially if you are on a low resource or resource constraint in any way environment, such as embedded systems, then it's especially true. And also, like, it gives you the look and feel of doing normal synchronous programming. So in here, if you notice, these are simple examples also, but you are it's just the same as it would be without async, except that you're declaring the functions async, and when you call them, you wait for them, and that's the only two differences you will see here. But we will get into the detail of how this is working and stuff in a bit. Then you say you wrote that code that I just showed, and then you want to call that one of the functions, and you do it like this, right? Or at least you would think so. And then if you write that code, it builds and it runs successfully, no warnings whatsoever. However, it wouldn't print anything, even though there were print statements there. So why on earth would it not print anything? That doesn't make any sense, right? And if you look at the code, the error that you will get from the compiler, like, it's not an error, sorry, it's warning. Sorry, I said that you will not get a warning, which I was wrong, because that would be really bad if you didn't get a warning either. But at least you get a warning from Rust. You get a warning that future is not used, and what the hell is a future, and what is this await, and what is polling? What does it even mean, like this whole error, right? If you're new to it, that's what you will think. the main thing that you need to know first is async functions. They return in reality behind the scene a future type, and future is a trait in Rust. It's I always dream of seeing the future, so I wanted to show you the future. And just like the dog, you wouldn't actually like to see the future when you see it. It looks like this. Um, if you mainly focus on the type part, the associated type of output, it's then becomes pretty simple to see it. It's a type that you can ask for an output from. It does have any processing needed or whatever to produce that output, and um, you call basically poll on it continuously until it yields that output, and you can there's an enum poll in the standard library for that. So if it still can't produce that output, it will say that it's pending. So a future has two states: either it's pending or it's completed. When it's completed, it's already, you would call it. You will get your output back. This is what I just mentioned is sufficed for now, but we will look into more later. Behind the scene, when you desugar it, like the compiler is handling the async part for you, but it changes it into something like this. It's actually a simple function that like you normally have, not async, but it returns something that implements the future trait that you just saw. And the return type that you declared for your async becomes the output type of this future. And these futures are inert. So that's why when there was this warning that you're not using the future. You created the future, so the async function that you called, it gave you a future, but you didn't wait for it. You didn't call it to completion. So that's why it didn't actually do anything. You just got the output. So we need an entry point to make use of this future that the async function is returning, right? So let's await the future. That's what the warning suggested, right? Like in the warning, it said like you have to wait for it. So let's do that. So in the main function, you call the same and then just add .await. I want to wait for it, but computer says no, because async is only allowed. That is the error you will get inside async functions and blocks. So how do we handle this? Enter runtimes. Like in Rust, you have something called runtimes, and it's not built into the standard library. It's not, at least right now, and I don't think it will be. And they are external. For many reasons, it was thought that it should be kept external, and people can provide it with different solutions for it. There are multiple runtimes available out there. There's single-threaded, multiple-threaded. Single-threaded one is like if you have a resource, as I mentioned, resource constraint environment, you don't want multiple threads launching, especially behind your back without you knowing. So in those ones, you will use single-threaded runtimes. But if you don't care, if you want things to be working as fast as they could be on your system, then you would probably want to use a multi-threaded runtime. And it's typically much easier to use a multi-threaded one. The single-threaded has some constraint on it. And the most common ones are Tokio and async std, or async std, however you pronounce it. And for the purpose of this talk, I chose async std because frankly, it just doesn't get enough advertisement as much as Tokio does. I thought I'll give them some advertisement. Although nothing against Tokio, I use Tokio as well. So yeah, what we do, we use something called block on. Actually, every runtime that I have seen provides this function with the same name, with the same semantics and behavior. So you use that block on and you give it a future, and it synchronously keeps polling it until it's complete, and it gives you the result. So that's how you will use it, for example. If you remember in the error I showed, it also talked about async blocks. It wasn't just saying async functions. So what are async blocks? you can actually create a future, anonymous future, just on the fly, just like you can create, functions in anonymous functions in Rust. You can also create anonymous futures just on the fly, and you can do it this way, for example, and you can use it just like any other future. But so far, what we have seen, you just keep waiting for things. So that's not really concurrency if you are just waiting for each thing separately, right? And one of the ways of achieving concurrency with async is spawning and tasks, spawning tasks. And actually, from what I know, also all the runtimes that I've seen, they call it a task. So maybe there's a runtime that calls it differently. So you have in Tokyo as well a task, and also in small as well, and in async std as well. So you spawn it, and it just takes a future, and it just spawned for you. In some runtimes, you have to specifically detach it. So detach means like just run it in the background. I don't care anymore. But in async std, it's the default. Like if you don't keep the return value of spawn, that task is then detached for you automatically, which is very useful, I think. So in here, it will just run those two, and then you can just sleep or do what other things, and those tasks are running in the background for you. And when it completes, it just goes away on its own. But tasks themselves are also futures. They implement the future trait, which is really cool thing about Rust. Like with the traits, you can add behavior to so many things, like your own types and stuff. So since future is implemented for task, you can use it as such. You can wait for it. You can do other things that we will see later. So, for example, combining futures, right? So, for example, you can. There's a crate called Futures, which is actually maintained and written by Rust developers and so like it's under the Rust Lang GitHub space. So it's quite officially, it's almost like STD, but it's not STD yet. So, and a lot of these API that exists in Futures Crate, it's planned to go into STD at some point. I think all of it, but I'm not so sure about that. But at least most of it will go at some point into STD in some shape. So anyway, so it's more like a proving ground. And there's one method there called join, and you can join multiple. It's actually a macro, so you can give it many different futures at the same time, and it waits for them at the same time, like all of them. And as soon as all of them are completed, it returns. So you can concurrently wait for tasks, which is what you want when your tasks are IO bound. As I said, like most of the time, what you're doing is waiting for something to happen, waiting for data to be available and stuff. So you just want to concurrently wait for events, and that's what you do here. And you have other goodies in Futures Crate as well for futures, like you can select on them instead of joining them. You can wait for either any of them completing. So if you just want any of them completing, that's what you would use. You would select on it. Or you can map them. So as I said, like every future has an output. So if you want to modify the output some way and create a future out of it, so you can just call .map and then map just like you do with results and options and stuff. There's a concept called streams. So in future you had one output. You consume the future, you poll it and it completes, and you get output, and that's the end of the story. But with streams, you keep getting it. You can keep getting output like until it's depleted, for example. And they're sort of like async version of iterators. Actually, when it will get into STD, the streams, most likely it will be renamed to async iterator, the stream type trait. So how do you use it? For a simple example, you just you have some helpers in Futures Crate that you can create futures out of some synchronous code, and sorry, streams, also futures, but streams as well. And in here we have something called repeat. You just give it some value, and it just repeats it. So the stream, each time you call next on it, just like you call next on iterator, you call it on the stream, but it's async, so you have to await it, and it will becomes it just keeps giving you values. As I said, similar API to iterator, like there's a lot of helpers available in future, and other also provided by the runtimes. Different runtimes provide nice goodies. But as I'm explaining async, and it's all cool and stuff, there's currently some limitations as well. And one of them is async traits are not possible. By async traits, I mean traits with async functions. And why is it not possible? Because Rust is supposed to be zero cost, the main APIs at least. And this is not possible right now. It's not possible with the current Rust Rust, all the features of Rust. It's not possible to implement it so that you can have, you can implement it with zero cost. You have to allocate to make async functions and traits possible. But worry not, you have nice trait called async, nice crate called async trait, and that you just use it like. Do I have an example here? Yes. So you just use it. It provides you with a macro, attribute macro that you use it on your normal looking trait, and then you can just do async fn. And in the reality, in the background, it's doing allocation. So as long as you're okay with that cost, you can just use this, and it's fine and it works. Similarly, for the same reasons, as far as I know, you can't have async closures. So you have to do something a bit complex. In here, you have a call that just takes a callback to call async callback, and just like you will define a callback in a generic way, you tell it it's a function which doesn't take any input, but it produces an output. But the output is a future, and that future has to implement the future trait with the output that you need. And that's how you'll use it. And then we use it, we call, and we just pass it a async, like we pass it a callback that just creates an async block, which implements future. So you can use it like that. And you have one of the problems of having runtimes external to standard library is that it's not really possible to write. Well, it's possible, but with a lot of hard work. I know from my own experience, I've been implementing an async API for the last many months that needs to be, or I want it to be agnostic of async runtimes out there. And it's super difficult. There's a lot of problems that you need to solve to achieve that. It depends also, like some simple things are very much possible, like you can provide a agnostic library, but a bit more complex where you have to read from sockets and transform what you read from sockets and stuff like that, then it's quite hard. And also you have like some small problems that can become big problems if you encounter them. And one of them is called async sandwich, sort of, where you call async. You call basically you call async from a synchronous from a async. So you have a sandwich. So you decided to run a runtime to run a future, but in that future down the line in the chain, it's right here. It's right directly under it. But in reality, you would encounter this problem where down the chain where you're calling a lot of functions, somewhere there you call a blocking function, a synchronous function, and that uses block on to run some synchronous async work. And then you have a problem because this can cause deadlocks. You can't run runtimes within runtimes. And actually, if you do it with Tokio, purely with Tokio block on, both inside and outside, you will get an actual runtime error. So that's a problem. But rest assured, the async working group knows all about all these issues. They have been informed, and they are working on solutions, proposing solutions to the greater Rust community and also to STD maintainers and authors. So yeah, that was a very quick introduction to async. So I'm sorry if I went very fast, but if there's any questions, I can answer. Yes.
Can you say a little bit more about how you approach building agnostic libraries?
So one helper that you do have is a bunch of crates written by someone called Stepan. He moved on from Rust a while ago, and he wrote this set of libraries. He actually wrote a runtime, very small runtime called Smol, SMOL, and that was divided into really, really small, tiny subcrates that have different functionality, like async locks. If you need asynchronous mutex or read-write lock or something like that, so you will use that crate, and it only provides that, right? And async channels. You want channels that are async friendly, works very well with asynchronous code. You use that. So those set of crates really help you out, but they go as not far enough, like you really. And also, like when he was going away, he said, "And who wants to maintain my project?" So I volunteered because I was depending on it so much. So I'm one of the co-maintainers now somehow. One of the things that wasn't there was async broadcast. Like there's async channels already, but there was async broadcast was missing. But he had a work in progress crate for that. So I picked that up with Yosh's help, and we finished that, and it's now published. And I actually actively maintain that because that's mostly my code now. Anyway, so you have that as well, broadcast. So there's a lot of those kind of crates, and also, like, if you're okay with it, Tokio does make it possible to use only subset of their crate. So you can, if you just need, for example, as I mentioned, locks, you can just enable that. You can disable all features, all default features, and you just enable the channels feature, and then or locks, and then you only have a crate that you're using that only has that. So that helps. But there are some problems that are not solved in a way that is agnostic to async. One of the ways that I did, like, I needed someone to continue, like, I had some task internal in the crate that needed to be run, right? How do I do that without using a runtime? And so I provided, with this help of the Smol, there's a async executor, and I just run that inside, but you have an option to run it yourself. So if you want to integrate it with your runtime very well, you can do that, or you can use the default, which is I launch a thread and I just run it behind your back, but it's just one thread, so it's not that bad. But I had to bite the bullet and run this thread because there was no other choice. Yeah, sorry, you asked for a lot of details, so I am giving, but we can talk later about it.
Another question.
You had some.
Yeah, I wanted to know how do you choose like between the runtimes? Like what is your criteria? Like which runtime to choose for a project?
That's not as easy a question as you would think, because there's people are very opinionated about it. Like we in the async working group, we were talking about like an example of a story. We came up with a story of someone wanting to move from Tokyo to async state, for example, and we came up with reasons why would they do that. But then the Tokyo guys came and like, no, that's not true. You can do this with Tokyo and you can do that. So it's a bit yeah. But I would say that try both, see which one works best for you, because there are different APIs. There's some APIs for some use cases in async STD are much better to use and easier to use for some use cases. But then the Tokyo ones are a lot better in terms of like they're very generic. So if you have generic problems, Tokyo usually works. But when you have some specific problems, that's my experience. I might be completely wrong about it, but that's my experience. That for specific use cases, async STD usually is to is the one you go to. Yeah. No. Oh.
Could you speak into this thing, please?
Are we async yet?
What?
Are we async yet?
Not really yet. We are working on it.
Maybe pass it on to the next one if there's one.
Don't be shy. I don't bite.
No, it's not.
Yeah.
Thank you so much.